All right, today we are on the B part of section 3.3. We're talking about using those properties of logarithms. We taught you 3 additional properties in the beginning part of this section. We worked on, of course, expanding our expressions, which you're going to see here in the warm-up problems. Today we're going to be doing the opposite, and we're going to be condensing them. Use properties of logarithms to expand the following. Now remember, expand means make it into a longer, more complicated looking problem. So recognize 15x, that's really product between them. Product, of course, expands into 2 logs added. Simple enough, you just got to know the properties. So log base 5 of 2 divided by x, division expands into 2 logs subtracted. And last but not least, we have this power, the exponent. So I'm going to use my power property. That can drop down into the front. I can rewrite that as 5 times, and you don't have to put the times symbol in, but 5 times the log base 6 of x. So just using our 3 properties just to do a quick little review. So today we're going to talk about properties of logarithms to condense problems. That's what we're really going to be focused on today. So condense, of course, means we want it into a smaller problem. Notice it says single quantity. That means you can only have 1 log in your final answer. That is it. So here I have 2 ln's added. I'm going to condense it into 1 ln multiplied. You're welcome to put the times sign in between y and z. Of course, that's not necessary. And yes, I have a single log. Same idea on B. We have 2 logs subtracted, so I can condense that down to a single log divided. And of course, for division, we're going to use our fraction bar. 8 over t. Nothing too crazy yet. Okay. C, again, we want to have just a single log. All of these should start with log, etc. Well, you have this 5/2 in here, so that really, of course, is the exponent. So I'm going to rewrite this as log base 7, z minus 4, raised to the 5/2. Because again, all of these a single log. So log of whatever you got. So a couple things here. We've got the 2 in the front. So of course I know that's really a power, so I'm going to think of that as x squared. And then I also have the addition to worry about. So 2 ln's, I'm going to condense that down to a ln multiplied. Addition condenses to multiplication. So I'm going to have x squared times x plus 1. You are welcome to leave it like that. You could distribute the x squared through. Completely up to you, however you want to write it. I would take either since they are equivalent. All right, let's take a look at a few more here. So same idea, we want to condense to a single ln. I see we have subtraction, so right away I'm thinking division. And this 2, remember, is really the exponent. Now I know some of you can go right to the answer. That's totally fine. I'm going to go ahead and put that exponent on, just do a little intermediate step here. And now I'm going to condense my 2 logs subtracted to a single log divided. So the ln of x divided by x plus 2 squared. Now you could FOIL out x plus 2 if you wanted. Nothing will simplify, so I'm just going to leave it as it is. Okay, F, same thing. First, I always deal with the numbers in front. Just think of those as your exponents. So I'm going to tack all of those on. Again, some of you can probably skip this step, but I'm going to put the intermediate step in where I write these with powers. And of course, order of operations, I'm going to work left to right. So the first thing I'm going to do is condense these first 2 ln's. Addition is going to condense to a single log multiply. So x cubed times y squared. I just didn't put the times symbol in, but we know that it's really there. And now I'm going to condense subtraction into 1 ln divided. So x cubed y squared divided by, I'm going to use the fraction bar, z to the 4th. And again, I know some of you can do more of that in your head and you don't need to write out every step. Just making it look good for your notes, of course. All right. Order of operations, there's a lot going on here. I'm going to start with grouping symbols, aka what's in the bracket. So I'm going to condense these 2 first. So addition condenses to multiplication. So z times z plus 5. And again, you are welcome to distribute the z through. I might if it's a little less to write. I'm just going to keep on going here, writing the rest of the problem down. Okay, I see, of course, we have some exponents happening here. 4 is going to have to be tacked as a power here. Same with the 2, so I'm going to do my exponents next. And let's go ahead and distribute z through here too, just to make it a little less writing. And then all of that has to be raised to the 4th power. So that's the other reason I distributed. I thought it'd be easier to write it all to the 4th power instead of like some weird double set of parentheses. and then I'm going to raise z minus 5 to the second power. Okay, I'm going to condense this down. 2 ln subtracted, condensed to a single log, divided. So my numerator is this crazy z squared plus 5z raised to the 4th power, and then my denominator, z minus 5 squared. Looks crazy, but that's as far as we can simplify on it. Just again, knowing the properties. All right, last one of these. Same thing, I'm going to work left to right. I'm going to think order of operations. So I'm going to do, of course, inside the brackets first, left to right. I'm going to condense these first 2 ln's. Subtraction, of course, condenses to quotient. And I'm just filling in everything else. Again, I'm still working inside the brackets. I'm going to condense this. This is going to look a little weird. We're going to have x over x plus 1. Subtraction condenses to quotient. So this is going to be a little bit of an issue because we have a fraction within a fraction, a complex fraction. So I am going to simplify it. I'm going to do this off to the side. So I have x over x plus 1. Now remember, when we divide a fraction, we multiply by the reciprocal. So I'm going to reverse that denominator, 1 over x minus 1. If I multiply across x 1, we could FOIL out the bottoms. It'd be less to right because it's conjugates. The middle terms will cancel. So we can skip that. So I'm going to substitute in, I should say, sounds fancy. I'm going to replace this complex fraction with x over x squared minus 1. Okay, last but not least, I'm just going to take this power in the front and write that as an exponent. So I'm going to have the ln, and I'm going to put this x squared minus 1. I have to raise that entire thing, so I'm going to put it in parentheses to the second power. So that one just got a little tricky because we had to do a little fraction simplifying. Just one of those basic algebra rules. You never have a fraction within a fraction. It's called a complex fraction. All right, last up. Find the exact value of the log without using a calculator. If it's not possible, state the reason why. So this is a flashback to some of those beginning properties we first looked at, some of these simplifying, where you want to write the base and the argument is the same value, which they have. Of course, those cancel out to your exponent. That's really a 1, 6 to the first. So final answer is just going to be 1, that easy. So next up, you're going to have a little bit of number sense and have to figure out how to rewrite 125 using 5. I just happen to know it's 5 to the 3rd power. You might need your calculator for that. I know it says without a calculator, but you might need 5 to the 3rd power in your calculator to make sure it's 125. Now, we want this as just power, not 1 over 5. So I'm going to cross the fraction bar. I'm going to bring it up, which means we can change our exponent, the sign on it, to a -3. Now, of course, those are going to cancel out and leave us with the power. Just a little bit of number sense here. Okay, I'm worried about this guy because, of course, I have to rewrite that -16 is 4 to some exponent. Well, I can't use squared. 4 squared is +16. I can't use -2 because that kicks it into a fraction form. So there's no exponent I can possibly use that's going to result in -16. Not possible. We can't do the log of a negative value. You can't make the exponent work out. All right, let's condense this one first before I do anything. I'm like, okay, I've got my 2 logs added. I'm going to condense it to 1 log multiplied. So 2 times 32, which of course we know is 64. Okay, same process. I'm going to try to rewrite 64 using the base of 4. Now you might need your calculator for this one. I just happen to know 64 is 4 cubed. Then of course my log base 4 and 4 will cancel and leave you with the exponent. So I know it says without a calculator. It just doesn't want you typing them in and giving some decimal or something goofy. It wants you using the properties to simplify. But you might need your calculator to know that 4 cubed is 64. All right, ln and e, of course, a couple different ways you could do this. ln and e cancel each other out. So I'm going to be left with 6. And then, of course, this would be multiplied. 2 times 7, 14. 6 minus 14. Another way you could do it, you could use the properties. You could condense this 2 ln subtracted, condensed to 1 divided. And, of course, that 2 is really an exponent. So power to power, we're going to multiply those. Now, e to the 6 over e to the 14, we subtract our exponents when you divide. So 6 minus 14, ln and e cancel. Either way you do it, you will get -8. Doesn't matter to me. Same thing on this. You could cancel the ln and e right away and recognize that's product. You could also take that 3 in the front and think of that power property, power to a power. We're going to multiply 5 times 3, and of course ln and e cancel. So different ways to do it, you will get the exact same thing. So hopefully not too bad of an assignment today. It's going to be a lot of condensing. I almost like the condensing a little bit better. I think it's a little easier versus the expanding. All right, have a great day.